Hello and welcome back to another video of the Brainy Heart. In this video, we'll be talking about the basics of the spinal cord. This is the first video of a two-part series. So, stay tuned for part 2 of this video. Anyways, in this video, I'll be talking about the basic structure of the spinal cord, its function, and its blood supply. Let me start off by talking about the function of the spinal cord. RSRM is what it does. Now, that's just the abbreviation that I use. What it stands for is relay sensory information and relay motor information. You could use anything else you want. The spinal cord relays sensory information from the organs to the brain, and it relays motor information from the brain to the organs. You can abbreviate it whichever way you want, and even if you don't want to abbreviate it, you could just remember it as it relays information from the brain to the muscles, and that's relaying motor information. And when it relays sensory information, it relays information from the organs to the brain. So that was a brief description of what the spinal cord is. So let's get right into it. The spinal cord has 5 different regions. This region is the cervical region. This is the thoracic region, and right under the thoracic region is the lumbar region, and then comes the sacral, which is a very small region, and finally we have the coccygeal, which is at the end of the spinal cord. So this is the order of the regions. So we start off with cervical, then comes thoracic, then lumbar, sacral, and coccygeal. And there are 2 enlargements, which is the cervical enlargement and the lumbar enlargement. The cervical enlargement is where your hands are. So there's a lot of neurons present in this area just for your hands. And in your lumbar region, there are a lot of neurons for your legs. That's basically where your leg basically starts. And your spinal cord also has a lot of vertebrae. So there are a total of 7 vertebrae in the cervical region. So you have C1, which is cervical vertebrae number 1. That's how they abbreviate it. You have C2, C3, C4, C5, C6, and C7. So that's where the cervical region ends. And then the thoracic, which has the most vertebrae, has 12 vertebrae. So it has T1, T2, T3, T4, T5, T6, T7, T8, T9, T10, T11, T12. And then right after T12 comes the lumbar region. And the lumbar region has 5 vertebrae. So you have L1, L2, L3, L4, and L5. And like I said before, right under the lumbar region is the sacrum. So the sacrum has 5 vertebrae, S1, S2, S3, S4, and S5. The coccygeal region has very, very small vertebrae, and it has 5, but as you can see, it's really, really small. So the cervical region is where your neck basically is. And then your thoracic would be your thoracic area, which is your chest. Your lumbar is where is like your lower back and where your legs start. And the sacrum and coccygeal go down to the rectum and anus. That's how the spinal cord is laid out. Also, since this is part of the central nervous system, the meninges also protect the spinal cord. And remember, the meninges are as follows. The dura mater as the outermost layer, the arachnoid mater as the middle layer, and the pia mater is the innermost layer.
The meninges, especially the pia mater, are very adherent to the brain, but the meninges in the spinal cord are less adherent.
Coming back to the spinal cord, I wanted to point out 2 more main areas of the spinal cord. So there's a group of fibers which is called the cauda equina,
And
The end of the spinal cord is the conus medullaris. I'll have to erase the circle that's showing the coccygeal region so that I can show you where the conus medullaris is. So the conus medullaris is obviously going to be where the coccygeal region ends, since that's the last region in the spinal cord. It's going to be this sharp pointy end. And that's basically where your conus medullaris is. That's where your spinal cord ends, and then there's a group of nerve fibers, like I said before, called the cauda equina. The final thing that I want to talk about in regards to the structure of the spinal cord is that your spinal cord is very wavy. It's not straight. So as you can see here in this picture, it is not straight. And there is a name for this. So this place where it curves in like that is called lordosis. And when it bumps outwards, it's called kyphosis. And then when it comes back into the lumbar area, there is lordosis. So it starts off as lordosis. So your spinal cord's bent this way, and then it's kyphosis, and then it's lordosis again. Remember, you should not have too much of a lordosis, or else you'll have some problems with your spinal cord, and you should not have too much of a kyphosis in this area, because if that's the case, then your body will be like that, which is not good for your body, because your posture will be very bad after that. You will basically have like a hunchback. And you shouldn't have too less of lordosis or kyphosis, because if the areas become straight, then these sharp vertebrae will touch, and when they touch, you'll have something known as a compression fracture. And this can be very painful. But remember, the cervical region has lordosis, the thoracic region has kyphosis, and the lumbar region has lordosis, and then the sacrum and coccygeal regions have a kyphosis. So here I have cross sections of 4 different regions. I have the cross sections of the cervical, thoracic, lumbar, and sacrum. And these pictures show us how much white matter and gray matter each region has. So this dark pinkish area is the gray matter. This dark pinkish area is the gray matter. And this light pink area is the white matter. And white matter is nothing but myelinated axons. The gray matter is where there is a lot of neuronal cell bodies and proximal dendrites. So as you can see, as we progress down the spinal cord, there is more gray matter and less white matter. And this bump in the thoracic region is called the IML. The IML is the abbreviation for intermediolateral cell column. And this is where there are lots and lots of cells that can be found. And this bump is only found in the thoracic region. And one way to think about this is that as you go down the spinal cord, more neurons exit the spinal cord, so there's less white matter and more gray matter. Think about it as a train that starts in your brain and then goes to the first stop, which would be your cervical, let's say, and all the passengers leave the train, or in this case, the neurons leave the train, and then the train goes to the next station, which would be the thoracic region, and all the passengers and neurons, all the passengers would get out, and there would be less passengers in the train. And then in the next station, more passengers would get out, and in the final section, almost all the remaining passengers will leave. So you can think of the neurons as passengers that start leaving, and the white matter is basically the neurons. So as the neurons leave, there's less white matter and more gray matter. And that's for motor information that's being sent out. For sensory information that's coming in, it increases as it goes up. Because when the train is empty, it starts all over again, starts in its first station, picks up some people, goes to the next station, picks up some people, goes to the next station, picks up some people, and goes to the final station, picks up some people, and then it repeats the process all over again. And then, in this case, the sensory neurons, collect as they go up the spinal cord, and then when they finally reach the brain, that's when you get your sensory information. That's how sensory information basically goes into your brain. And remember, motor information is efferent, which is exiting information, and sensory information is afferent, which is arriving information. So you can easily remember this by remembering the first word of the letter. So efferent starts with an E, which is the starting letter of exit, and afferent starts with an A, so arriving information. So that's one way to try to visualize why the white matter decreases as we progress down the spinal cord.
Finally, I want to talk about the blood supply to the spinal cord.
So this area where more arteries branch off from, the two circles represent the dorsal arteries. If we draw a line right through the spinal cord, if the line is cutting the spinal cord in half, this would be the ventral side, and this would be the dorsal side. So the dorsal is the posterior meaning the back side, and the ventral is the anterior, meaning the front side. And the dorsal part of the spinal cord is responsible for sensory functions of the body, so all the afferent information, and the ventral part of the spinal cord is responsible for the motor functions, so all the efferent information. Anyways, coming back to the arteries, we have the ventral artery on the ventral side, and it branches off into smaller arteries, but it supplies blood to the ventral part of the spinal cord. And you can have a stroke in one of these arteries, and which means that you could get paralyzed, or you could lose some of your sensory or motor functions. But that's how your spinal cord gets supplied with blood. And yeah, that was blood supply to the spinal cord in a nutshell. That was it for today's video. I hope you enjoyed it and learned from it. I'm always open to comments, questions, and/or suggestions. Also, check out my blog at brainyhearts.wordpress.com. This is a Brainy Heart signing off. I'll catch you later in the next video.